Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the conversion of JK flip-flop to D flip-flop. Okay. So, let us start. This topic is from sequential logic circuits. The subject name is digital electronics. So, let us start the solution. We need to convert JK to D. So, what is given to us? JK flip-flop is given. JK flip-flop, we need to convert this JK flip-flop into D flip-flop. JK flip-flop is having two inputs J and K and two outputs Q and Qn bar with a clock pulse Cp negatively edge triggered. So, it is a bubble at the input side. Now, we need to convert this JK flip-flop to D flip-flop. For this conversion, we need the excitation table which is having 4 columns. One is the input state, present state, next state and flip-flop inputs. So, what we are doing here? We are converting JK to D. So, what is the input now? D. D is the input. So, I have written input as a D. Present state is Qn. Next state is Qn plus 1. What are the flip-flop inputs? For the given flip-flop, what is the given flip-flop? JK. So, the flip-flop inputs are J and K. Now, we need to fill this excitation table. So, we have written the 4 binary combination for the first 2 columns, that is a D and Qn. So, D and Qn we can write it as 0 0 0 1 1 0 1 1. To fill the next state, we should know the truth table of D flip-flop. So, you know the D flip-flop truth table. This is a D truth table. Truth table will have D and Qn, that is a D and Qn is a present state, Qn plus 1 is the next state. So, whatever is a D column, the same will be reflected in Qn plus 1. What is D flip-flop? Delay flip-flop. Whatever is the input, it is appearing at the output with certain delay. So, whatever is the D input, the same will appear at the Qn plus 1. So, we can write it 0 0 1 1. This is the D truth table. So, we can fill this next column here. So, whatever is a D, that is 0 0 1 1. Now, we need to fill this flip-flop inputs. To fill the flip-flop inputs, we should know the excitation table of JK flip-flop. The excitation table is written between Qn and Qn plus 1. Okay. So, when it is 0 0, it is 0x. For 0 1, it is 1x. For 1 0, it is x1, and for 1 1, it is x0. This is excitation table of JK flip-flop. So, now to fill this last 2 columns, we should fill this excitation table here. For 0 0, it is 0x. For 1 0, 1 0 means x1. For 0 1, 1x. For 1 1, it is x0. Okay, up to here it is clear. So, to fill the excitation table, this one we need truth table of D flip-flop and the excitation table of JK flip-flop. If you remember these 2 tables beforehand, it will be easy for you to fill this excitation table. So, what we have done in this excitation table? We are having 4 columns: input, present state, next state, flip-flop inputs, and then written the binary combinations for D and Qn, and then written the Qn plus 1 column for D flip-flop, and then written the excitation table for JK flip-flop. Now, from this excitation table, we need to solve 2 K maps. One is for J, another is for K. So, how many variable K map? It will be 2 variable, that is between D and Qn, which I have drawn it here. A 2 variable K map, one for J, another for K. 0 1 0 1. So, let us fill this J values in this binary in the K map, that is 0 x 1 x, okay, like this. So here one group is possible, that is forming a pair. So for this pair it is 1 is D. So what is J equal to? D. Now let us fill this K variable. So let us fill it x1 x0. So here this grouping is possible. For this pair the term is coming to be a 0, or 0 means D bar. So what is K equal to? K is equal to D bar. So in this way we get J as D and K is equal to D bar. So we will have one common input D, which is D is going directly to J, and D bar, that is through a NOT gate, is going to K. So in this way we can convert this JK flip flop to D flip flop. Okay, so this is JK to D. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.